Okay, for this video, we'll be going through 2023 Combined Science Physics WA3. Yes. Okay, let's start. Okay, so for question 1 in your MCQ, a force is applied to a wheel at point P so that the wheel is on the verge of rising over the step. Which of the forces A, B, C or D is the smallest? So when I look at this question, it is a moment's question, okay, because the wheel is going to be turning. So anything that turns, okay, you can link it to moment's question. And if this wheel is going to turn over this step, it is going to be rotating clockwise. So this is going to be my pivot, okay. And since the formula for moment equals to force times perpendicular distance, okay, and we assume that the moment, the turning effect, because it's on the verge of rising over the step, we assume that the moment it is the same, okay. So now we are actually looking for the force that is the smallest force. So if I want my force to be the smallest, that means my perpendicular distance must be the largest, okay. So this is testing you on how to find the perpendicular distance. So remember the 6 steps. So firstly is determine where's the pivot. So the pivot is over here. And then since there are 4 forces, we need to determine 4 perpendicular distance of their line of action of the force. So how do we draw line of action of the force? For A, it will be just extend, take a ruler and extend. Okay, so for A, this is the line of action of force for line of action for force A. Okay, line of action for force A. And since this is the pivot, I'm going to just do this example first. This will be the perpendicular distance for A. Okay, so this is perpendicular distance of A. Okay, I hope you can see this perpendicular distance of A. Then we can do the same for B, but I'm going to change the color to red. Okay, so for B, it is this way. You just take a ruler, draw the front and back. And here is the pivot. So this will be actually the perpendicular distance for B. Okay, then we do it for C. Another different color. Okay, so for C, after we draw the perpendicular line of action of force C, this will be the perpendicular distance. So as you can see for now, A's perpendicular distance is the smallest. For the red color one, which is this line over here, it is actually so far the largest, right? For C, it is a vertical height, but this one, the C, for red color perpendicular distance is going to be the largest. Let's do for D, then we can come to a answer. Going to use this color. So this is the line of action of the force of D. So remember, always draw the line of action of the force, and this is actually the pivot. So this is the perpendicular distance. So answer is actually B, okay, because it has the largest perpendicular distance. So the force will be the smallest. Okay, question 2 is also a moments question because they say position of the center of gravity of the entire setup. So this thing is actually stationary, in equilibrium, not moving, okay. So there will not be any turning effect, okay. So can you just visualize, if this thing were to topple, you either topple this way or topple this way, correct? So the pivot is somewhere here. The pivot will be somewhere here. Therefore, answer will be B, because if the center of gravity, okay, so center of gravity, it is a point where all the weight seems to act in. It is a point, okay, where all the weight seems to act in. So for this center of gravity, it is a point. It is not a line. So if it's this point, then the weight will seem to be acting here. And because our line of action of the force of the weight and not the center of gravity, I repeat, the line of action of the weight passes through the pivot, there will be no moments, right? Because moment equals to force times perpendicular distance, and since the perpendicular distance is 0, therefore the moment will be 0. So answer will be B. Okay, question 3, it is about energy, right? It is released from rest. That means over here the velocity is 0. That means the KE, or the energy in the kinetic store, is 0, but it has a certain height, right? So based on this, where A is the lowest point, A being the lowest point, okay, there is a vertical height. And since there's a vertical height, then there's going to be energy in the gravitational potential store. So there's going to be GPE. Okay, so where's the furthest position the ball could reach? Now, if I were to compare this, and let's say that it is a frictionless slope, okay, the maximum height that it can reach is B. It will not be able to go over to C, because if you look at C's perpendicular vertical height, it is actually greater than the vertical height of A. So if it's greater, there will be no way that it can actually go higher than that. So answer is actually B. Okay. Question 4. A man pulls a cart over a distance of 20 meters as shown in the 3 diagrams. Which statement concerning the work done against gravity? It's not just work done, it is the work done against gravity is correct. Okay. So if let's say the man pulls it 20 meters, and if it's to do work against gravity, that means the direction, that the force that he exerts must be vertical. So over here, he rises above this height. So this is H1. And for this is H2, right? Because over here, he doesn't need to do work against gravity. He will just be pulling horizontally. But here, he still need to maintain a certain vertical pull. Then for 3, it will be the same like this, H3. So you can see that H3 and H2 will have the same vertical height. But for H1, it is actually higher. Therefore, most work is done against gravity in 1. Okay? So the work done against gravity will be the same for 2 and 3. Work done for 2 will be equals to work done for 3 against gravity. Okay, because they rise up to the same vertical height. Question 5. A worker lifts a box weighing 240 Newton. This is the force through a distance. This is the lifts a box. That means this is going to be the vertical height. 4 seconds, it is time. Take note that everything in this work energy power, it is must be in SI unit. Work energy power, WEP, stands for work energy power and not weight, energy and pressure. No. So what's the power exerted by the worker? So what is power? Power is the rate of conversion of energy. Okay, so therefore I need to find what is the energy needed. So energy, it is force times distance moved. I can use F times H over T. So the force is 240 times the height of 1.5 over T is 4. So I will get 90 watts. Okay, take note that the unit for power is watts. Okay, question 6. It pulls a box with a force of 500 Newton. So annotate as F across a rough floor. That means there's going to be friction. A frictional force of 100 Newton acts on the box. Okay, so if I were to draw the free body diagram, I pull it with 500 Newton. There is a frictional force of 100 Newton. So how much work is done against friction? This is important. So against friction, the force is 100 Newton and the box moves a distance of 3 meters. So the force of friction is 100 Newton in, let's say, to the left. The distance moved is opposite, right? So I actually need to overcome this force of 100 Newton, right? So the answer will be work done against friction, force times distance moved in the direction of the force. So this energy that I need to do work against the friction will be 100 times 3 equals to 300 joules. So answer is A. Okay, so that's all for your MCQ. Now Then now we come to structured question. 1A, state the principle of moment for a body in equilibrium. So this can be found in our notes. Then figure 1.1 shows a windsurfer balance. That means it is in equilibrium. Okay. In equilibrium, the wind is exerting a force on the sail of his boat, of his board, right? The weight of the windsurfer is 960 newtons as shown here. Okay, so this is the force of the wind. Now calculate the moment exerted by the weight of the surfer about point P. So this is about moment question, and moment equals to force times perpendicular distance. But now they just want us to find the moment caused by the weight. So the weight is 960, so we draw the line of action of the force for the weight, and this is the pivot. So actually the perpendicular distance for the weight, it is 0.4 meters. Okay, so remember, finding the perpendicular distance is often what students find difficult. Okay, so please practice. So 960 times 0.4, so answer will be 384 Newton meter, because the unit for force is Newton, the distance is in meters. Now using principle of moments, calculate the force that the wind exerts on the sail. So this is the force of the wind, and the perpendicular distance for wind, for line of action of the force for wind, is 1.2. Okay, so since it is balanced, that means I can apply principle of moment. So this 384, okay, it is actually in a anti-clockwise direction. So for the wind, it is actually clockwise. And since there are no other forces, 384 will then be equals to the force of wind multiplied by its perpendicular distance. So the force of wind will then be 384 divided by 1.2. So answer will be 320 newtons. Okay. Okay, stay and explain what the surfer needs to do to remain in equilibrium when the force exerted by the wind on the sail increases. So that means the moment that is caused by the wind will become larger. Okay, so let's take a look at the answer. Okay, when the force of the wind increases, the surfer needs to lean backwards. This is what the surfer needs to do, his action. Now, leaning backwards increases the perpendicular distance of his weight from the pivot. Therefore, it increases the anti-clockwise moments to keep the sailboat in equilibrium. Remember, just now we talked about it. The weight of the sailor actually exerts a anti-clockwise moment, but the force of wind actually exerts a clockwise moment. Since the clockwise moment has increases, he needs to lean back so that his anti-clockwise moment will then now be equal to the clockwise moment, so that he can remain in equilibrium. Okay, question 2, it shows a man of mass 100 kg, so this is M, lifting 1600 newtons of weight through a vertical distance of 2 meters. So this is the force that he needs to exert, and this is the vertical height that he needs to move the weight up. So calculate the work done by the man on the weights. So work done is force times distance moved in the direction of the force. So the force that he needs to exert is 1600, and he moves it a distance of 2 meters. So the work done is 3200 joules. Just make sure that everything is in SI unit. Now the center of gravity of the man and the weight is at point G. So this is where the combine, or where the for the man and both the weight, the center of gravity is over there. So why must the man stretch out his legs to maintain his stability? Let's look at the answer. Okay, so for stability, in order for something to be stable, right, the center of gravity must be as low as possible, or the base area must be as large as possible. But since the weight is at the center of gravity is at point G, so we cannot reduce that, but he needs to spread out his leg, because by stretching out his legs, his base area becomes wider or larger. Okay, so we still need to explain the weights must be tilted at a larger angle for the center of gravity to fall out of the base area. Therefore, it is more stable. Or the line of action of the weight does not fall outside the base area. Okay, so when that happens, there is no moment, so he can be more stable. Okay, question 3, it shows a 80 kg jumper. So this is the mass taking a part in a long jump competition. He runs from a certain distance and then leaves the ground with a horizontal speed of 5 meters per second. So 5 meters, that means over here his velocity or speed is 5 meters per second. That means that's going to be KE. Okay, after a short while he lands at a position away from the jumping point. The G is taken to be 10 Newton per kg. State the principle of conservation of energy. This one can be found in our notes. Describe in detail the energy changes from the moment he jumps to the point where he reaches his maximum height. State an assumption that you have. Okay, so let's look at the answer. Okay, to answer this kind of question, you usually need to state the kind of conversion that happens and the pathway. So as the jumper jumps to the maximum height, the energy in the kinetic store in the jumper is transferred mechanically to the energy in the gravitational potential store. Okay, we bolded the store because now you need to use store and you need to use transfer, and mechanically is actually by the pathway. How is this thing achieved? How is the transfer achieved? Now, assuming assumption is that there's no energy transferred to the internal store of the surrounding, or we assume that there's no air resistance. Okay, this is just an assumption in the ideal world. So if there's no air resistance, then don't have to do work against air resistance. So all of the energy in the kinetic store will be transferred mechanically to the gravitational potential store. Okay, they want us to calculate the amount of KE the jumper has at the jumping point. So for KE or EK equals to half mv square. Okay, again, make sure everything is in SI unit and his mass is 80. His velocity was 5 meters per second. Let me put in my 5. Okay, so if you do your calculation correctly, you'll get 1000 joules. Okay, just take note that the square belongs to the V only. Now determine the maximum height. Since we already assumed that all the energy in the kinetic store will be transferred to the gravitational potential store, so EK will be equals to EP. No energy that's transferred to the surrounding, right? So 1000 joules equals to mgh. The M is actually how much? 80. So 1000. 80. The G is 10. So what's the height? Then you can do a calculation and the height will be 1.25 meters. Okay, so that's all for this video. Please watch it and I'll also upload the answers.